All right, so today we're going to talk about network topology. Okay. Now, this week consists of recognizing the network types and network topology. So you're going to get you already have, for the first group, for the other group actually, we have the network types that are posted on our playlist. Now, in online today, you're going to get the network topology and the network types. You're going to get in person next time we see each other, whenever that is. I'm still learning my schedule here. All right. Okay, so let's not wait any longer because we don't want to burn the daylight. All right, network topology. You need to know that stuff when you're dealing with things like network infrastructures, which basically this course is all about. I know it's called network cabling, but it talks about in a broader way of as far as network infrastructures. I'm giving you the whole insights of the business in which I have been. Oh wow. Quite long time, probably way before the Dead Sea got even sick. So anyways, topology. You need to know what people are talking about when they talk to you. Also, the other why thing is if you work for somebody else, for another company, yes, you need to know this stuff. Especially if you decide to work for on your own, and you might make that decision before long, actually, right? Time goes fast. All right, so topology is the way that the networks are arranged, and there are some symbols that represent types of network topology, which is type of the way the networks or structure is arranged, okay? Now, there's some of the symbols. There are way more, but we're going to narrow it down. And we're going to even narrow it down even more to some of the basic ones. We're just going to concentrate on the ring, star, inline or chain topology, and the bus topology as far as things are connected. Definitions. Let's get that out of the way. Network topology is the arrangement of a network, including its nodes. We'll talk about what those are, and connecting lines. Now, also, there are two ways of defining network geometry. Physical topology and logical or signal topology. By the end of this class, you will know the difference between these two. All right, boom. All right, basic elements of a network presentation. Hosts or nodes. Hosts or nodes, what makes one up is any kind of a smart device that is connected to a network. And also we're going to be talking about connecting links. All right, so for the hosts or nodes, will be computers, PCs, or whatnot, wireless access points. I don't think there should be an apostrophe there. The routers, switches, hubs, bridges, gateways, and the list goes on. Anything that connects the network, and it's considered as a smart device, which means it's implementing some kind of a internal logic, and and that device will be connected to a network. Also, we can go as far as printers and other devices, such as, for example, IP cameras. IP stands for Internet Protocols, so that will be the camera that connects to a network. Now, for the connecting links, just get that thing here. Connecting links, we distinguish basically three type of mediums that we're going to concentrate on, which would be copper, fiber, or air. Copper is the connecting links that are made out of metal type of wires, conductors, Ethernet cables, signal cables, speaker cables, service cables are providing power. Fiber optics and air, because sometimes you do need to connect to a network in a wireless way, so using electromagnetic waves, radio waves. Okay. All right, so the first one on the go, we're going to talk about something called the ring topology. Here is the symbol for a ring topology. And in that, so these little dots or those circles here represent the nodes or devices, or otherwise known as hosts. Each node or host connects to two adjacent nodes in a continuous pathway for signals through each node. All right. Data travels from one node to another with each node along the way, handling every data packet. Okay, so if this node wants to communicate with this node here, it is going to start sending the message, and it's going to send it this way. Let's say this is number 123. Here's a message from 123, and this guy is going to receive that. It says, am I 123? No, I'm not. This message is not for me. I'm going to repeat that message and pass it along until it gets to this addressant here. Okay. Then whatever the message is, whatever the signal is, then it's going to be processed, and sometimes a response is required, and sometimes it's just whatever passive response is required. Display something, display a giraffe on the monitor. Now, do I have this thing as the next? Okay, every node acts as a repeater. Now, ring topology hardware. Also, I'm just going to come back to that slide right here. There is a way of describing the ring topology considering the data flow. This is a ring topology when the data travels only one way. Let's say clockwise. Let's say that. And it's called a ring topology. There is another name for a ring topology when the data can travel both ways. So if this link is broken, that message is not going to go that way, then the machine or whatever the device is going to try to send the message the other way in order to get that. And that is called a token ring. I'm getting ahead of myself a little bit. Ring topology hardware. Well, here is something that would be called a single port network interface card. Now, this is a bigger version of that would go into the slots on the motherboard on a PC. However, laptops, tablets, and whatnot, they do have a miniature, smaller version of that, but still it will be called NIC as a network interface card. And it's single port because it does have a single Ethernet port in this case. Excuse me. Now, we can have a double port network interface card. All right. Here, which network interface card can be used in a ring network? Single port or a double port? Can anybody pipe in on voice, or maybe you can just write that in the chat window and I will see it. Anybody at all? Anybody? I think there was kind of a, there you go, single and single port for the ring topology. We get a bunch of singles here. Well, you are, I would say, 17% right on this. Now look at this here. Oops, where am I here? Here is the symbol, just to look at the symbol of the ring topology, well, network arranged in a ring topology. Each node has how many connections? All right, as I said, there you go, 2. That's very good. There are 3 kinds of people in this world, ones who can count and the other ones who can't. So that's very good. So would you rather use, in order to make things easier for us, would you use the single port network interface card or double port NIC for each device. All right. Somebody say something. Double port. There we go. Because we have two connections. Now, the other 17% of rightness I reserve for something that's called, well, logical topology or logic type or signal flow topology. You can arrange devices in the network with just a single ports, and still you can make that work as a ring, but it involves some extra gymnastics, and to the point that we can just say that technically it is possible. And we'll talk about that in the next few slides. All right, where are we here? All right, now ring configuration. This is just another visual on how the data flows in the ring topology. Now, remember when I talked about ring versus token ring? In a ring, data flows only in one way. And in the token ring, data can flow both ways. Applications. One stands for wide area network, and you will know a bit more about it in the second part of the lecture that you're going to receive next time we see each other, or metropolitan area network. It also can be implemented in the LAN, local area network environment. But let's take a look at this first. Here's a visual of few buildings being connected to each other, acting as a network. For whatever reason they need to be connected, they just are. And some of them are connected through the fiber optic lines. Some of them may be overhead or telephone lines, or some of them could be connected, or Ethernet as well, if they're close enough to each other. Then some of them are connected in a wireless way. So quite often, not just one type of medium is being used for connecting the, well, in this case, the building would be a node in the greater scheme of things. All right, now, where's my, okay, so token ring. If there's any link that is broken or malfunctioning or busy or for whatever else cannot be used, the data can be passed on the other way, so it gets to the appropriate node that the message is for, or the packet. Now, in the LAN configuration, how things are being done in the LAN configuration? Well, you will have a bunch of data jacks. For example, if it's a Ethernet network, you will have data jacks all over the desktops, offices, walls, ceilings. Basically, what I'm saying is in the field, and the field means it's the rest of the building. Okay, it's considered a field. So field wiring, you'll be the building wiring. Okay, so and every single data jack is connected individually by a dedicated physical Ethernet cable to the main distribution frame or main communications closet. There are different names for that. Local area network room. Everything home runs. Okay, now. Where are things connected? From the data jack, just imagine there's a data jack here, and there's a wire goes into the LAN room, and it's terminated at something that's called a patch panel. Patch panel embeds physically a bunch of data jacks, so they could be compacted into one, confined. I don't want to, okay, maybe I shouldn't use the word confined space because it's something else. Limited space, all right? So just to save space, we would have a frame on which we would have a bunch of data jacks there, and that would be installed in equipment rack. So there's a dry connection between a data jack in the field and a data jack in the patch panel in the LAN room. Well, things have to be connected somewhere. In the field, the data jack could be connected with the patch cord to a PC, to a wireless access point, to any kind of device that needs a printer, or other devices, or a camera. So that is connected to a device. Now, on this side here, things also have to be connected somewhere. We have things that are called switches, and switch in the Ethernet environment, in the local area network environment, is a smart device that acts as more or less as a traffic controller for all the signals and data traveling and being passed on wherever it needs to go. So switch will also have a bunch of ports. Now, these ports are active ports. They're connected electronically to the electronics inside the device. That's called a switch. And the switches could be as simple as 6-port switches, 12-port switches, 24-port switches, 48-port switches, or whatnot. Quite often, the amount of ports on one switch is not enough to accommodate all the data connections that are in the rest of the room. So sometimes we're going to have to add another switch into the equipment rack, or maybe more switches, more than one. In this case, let's say we have 4 switches. Now, those switches have to be connected to each other in order to act as one big switch. So, in this case, as you can tell, these 4 switches are connected in a ring topology. And everything else into the LAN room is home running, so it's connected in something that's called a star topology. All right, now, as a homework, I'm going to ask you to watch a couple of those videos here. Now, this one here is 7 minutes and 21 seconds. Please watch that. I want you to know what the difference is between a hub, the switch, and the router, at least those 3 basic things. This is the terminology that is going to be used whenever you're going to be dealing with service calls, new installations, and all that stuff. You will not be asked to set those up in this type of business. However, some basic knowledge on how to set some things is recommended, but it's not necessary. Whenever you are going to install anything like that, you will not have the administrative rights anyways to set those up. If there is anything that needs to be set up, you will need to have your laptop. Having a laptop is an integral part of this business, that sometimes you're going to have to call something's called a level 2 support in order to find out what the password is, and maybe they'll tell you to input some data in certain spots, okay, according to whatever their setup is. So you need to know what these are. Right? Now, here's just an example of how to set up ring or chain topologies, very similar, of different switches. This is a complex type of a video. However, I'm going to ask you to watch just the first 1 minute and 42 seconds of that video, just so to get some sort of idea what's happening in the field. All right. Next thing here is we're talking about a star topology. Here is the symbol for a star topology. Here's one main node and satellite nodes. Everything. So we can just say all roads lead to Rome type of idea here. Okay. So everything home runs to the central location. Okay, what did I write here a couple of years ago? Each node or host of a network is attached to a central node, right? Just like that. The central node is usually a hub or a switch. There you go. The central node can also be another proprietary device, which proprietary is another way of saying dedicated device, such as NVR, stands for Network Video Recorder, or well, in case of camera video surveillance system. It doesn't have to be a server such as a network server or something like that. Other systems use the same topology. Star topology is here's the statement. Star topology is the most common physical wiring configuration, emphasize on the physical wiring configuration, considering horizontal network wiring. Okay, I'm throwing terms at you left and right here, right? Right. Okay, let's take a look at some of those things. That comes up, whatever the horizontal network wiring, it's coming up in the next few slides. Here is another visual on how star topology works. Here are a bunch of PCs. Here's a switch. Everything has a dedicated line that home runs, another terminology. Bunch of home runs. The wires or the cabling is configured in a home run type of configuration. Every single wire home runs to the central location. How does it look like in reality? Star topology, LAN, local area network. All cables, again, home run to one common point. And it would be a patch panel. So here is how things look like from the rear of the equipment racks. Every single data wire runs somewhere to a dedicated data jack. There's a lot. So for example, here would be a 24 port patch panel. So here's 24 ports, here's 24 ports, here's 24 ports. Now look at how many 24 ports are here. That will be a big project. Okay? Notice one thing I'm going to make just a small, tiny digression. Look how those cables are bound. They're not using zip ties. It's Velcro. Just keep that in mind. Okay. Now over here also it's Velcro. We'll talk about that a little bit more as when we get to the category type of cabling specifications. I don't want to spend too much time on that because we have a designated lesson on just that. So this is how things look from the rear. And this is how things look from the other side. Here will be a patch panel, for example, here. And the patch panel, each port on the patch panel is connected by a dedicated patch cable into a switch. And sometimes it doesn't matter which ports of the switch you're plugging in as long as everything is plugged into a dedicated port on the switch. And sometimes the ports on the switches are designated to perform special functions and have designated rights and restrictions and whatnot. So that's not our job to determine. It is the IT personnel or the people who set up the networks, and it's their job to give us the information what needs to be patched into what, or sometimes it just doesn't matter because the switch is going to take care of the signal routing. Yeah. All right, remember when I talked to you about something that's called a horizontal wiring? Like we have 3 floors in the building. Here's a floor, and of course here's another ground floor. Over here we have a bunch of data jacks or field wires. Here's a field wiring that goes into this floor. And over here you have, well, it could be called telecom closet, could be called distribution frame, it could be called LAN room, or secondary demarcation point. There are different names for that. There's a room with where all the IT equipment is, lives. Now, usually in modern construction, those rooms, those telecommunication closets or those LAN rooms on each floor, they will be arranged so they're in something that's called a riser configuration. That's for the ease of routing wires because when the building is built, it's not just that, okay, the wiring is done, bang, you can just close the walls and there's no need for running any additional wires. It's just like saying that, going to a music store and buying a guitar and just, make sure that the guitar is tuned, because I don't want to buy a guitar that's out of tune, right? And then, is your guitar in tune? Yes, it was in tune when I bought it. So same thing here. The wiring constantly changes. Things are being replaced, wires removed, replaced with other ones. Other ones are being additional wires. It's this whole revolving door as far as wiring. So the riser is supposed to make that easier for us. Okay? So this here, all those wires that home run to this communication closet are considered horizontal runs because they are confined to this communication closet. And so on here and so on here. And this will be the horizontal wiring. And here will be vertical type of, but we don't say it vertical, we just say riser. Here's a riser. Now, just for kicks, we can consider scenarios such as this. If this here, PC, would be connected, the wire would be run here and upstairs and connected to that closet, then this PC would be part of this horizontal wiring, okay? Now, what else do we have here? We have main cross connect and we have intermediate cross connect. Now, see, the terminology can vary depending on who uses what kind of definition. This could be also called right here, demarcation point. A demarcation point stands for point of entry. Usually it will be in some kind of a bigger communications room or electrical room, if it's a smaller venue. So sometimes the communications demarc point is in a different room than the electrical room, depending on the configuration of the building, the size of the facility, and whatnot. Now, you can also call this thing frame. You can say main cross-connect frame, or you can say main distribution frame. In short, MDF, main distribution frame. All these can also be called frames, but there will be secondary frames. And just to make things look smarter, they're called intermediate cross-connect or intermediate distribution frames, also known as IDF. Next time you go to, I know Home Depot has that. Okay? Go to Home Depot, for example, and look at the walls around that inside of the building. You're going to see black boxes that are basically a small fridge size. And on those, you're going to have huge lettering labels, IDF A, IDF B, IDF C, and so on. They are just labeled. They are strategically placed around the building, so the wiring, copper wiring or Ethernet wiring, is no longer end-to-end than 300 feet. 328 feet, but we just don't want to exceed 300 feet because you still want to include some space for the patch cords. Right? They also have length. So in that building, you would have one MDF that would be connected with fiber optic lines to a bunch of other IDFs, intermediate distribution frames. There will be only one main distribution frame, and there will be multiple IDFs, intermediate distribution frames. Structured network cabling, like over here. Most popular physical topology is the star topology. And that's what more or less things look like. Here's one big patch panel, maybe a switch, and here's the horizontal runs connected to whatever. In this case, bunch of PCs, but it could be other devices. Now, here's a bus topology. A bus is just like one main river of signal wire or other kind of medium with everything tapped into it. All right, so here's a T-tap, here's a T-tap, here's a T-tap, and so on. This is the old ways that the computer networks were installed up to about mid-90s or something like that. Then the Ethernet cabling came in. Another example of bus topology would be, well, radio, electromagnetic waves. What serves as a bus? The air serves as a bus. There's one antenna broadcasting the signal over the air, and if you're driving to school in your car, you turn on the radio station. With that radio in the car, you're tapping in to that main signal that is available for everything, for everybody. Here's the symbol of that. There's one main line here, and there are devices that are tapped in, well, quite often in parallel communication. The PA system that we just connected this week is also, if you remember the way we connected those speaker stations, those constant voltage distributed audio speaker stations, that also is technically a bus configuration. Now, how are things, because those speakers is just one-way communication, the speaker just receives the signal and so on. There are also smart two-way communications, and just like the radio waves, walkie-talkies, you can talk and you can listen through that. Same thing here. Something that's called multiplexing is utilized in order for two-way communication using just one pair of wires, for example. All devices are connected. Bus topology was used in LAN up to early 1990s. I have to keep changing the dates every year. Presently, all LAN systems are wired in star configuration. Bus topology. Now say, although bus topology is not used in the LAN setting anymore, it is still implemented in other systems. Like, for example, if you look at a fire alarm zone, here's a fire. Okay, what is a zone in the fire alarm? Zone is a connecting point that can serve as a detection point. Into that detection point, you could connect one device, or you can connect multiple devices, and designate it as maybe east hallway pull stations are connected to that connecting point, or it's called zone. A fire alarm panel can have multiple zones, and they can be wired into different things. Like, for example, you can have pull stations on one zone. You can have certain area smoke detectors connected to another zone. You can have heat detectors in certain area connected to another zone. You can have air duct smoke detector and so on. Right? How does that work? This is the most primitive way of presenting a bus so things can be understood. Here is a zone, a connecting point, detection point, as one of many on the fire alarm panel. It is connected to something that's called an end-of-line resistor, and usually it's 4.7 kilo ohms, but it could, well, depending on manufacturer of the equipment, this thing could vary. Now, all these devices are normally open. Okay. So there has to be some way of detecting that there's no problem with the line by the means of end-of-line resistor. That point here has to see that certain resistance, and based on that, it says, okay, the line is good. Now, if there's any device that triggers, it's just going to produce a dead short, and that's how it's going to trigger the alarm condition in the fire alarm panel. If there's a broken line, then the zone is going to see wide open, which is like infinite resistance, and it's not going to go into alarm, it's going to go into a trouble condition. But without going into too many details, this is a bus configuration, probably the most primitive way of picturizing it. Now here's a security alarm, right? What do we, oh, look at that. This one says bus right there. how things are connected. I'm going to skip the power connection because every keypad, for example, would have 4 conductors. 2 conductors to connect the power to it, and 2 other connectors to connect the signal. So I'm just going to skip the power just to make things not as polluted graphically. So look at that here. Everything is connected in parallel communication, parallel way. But each keypad communicates with the main board on individual basis. Same as radio stations with the radios, two-way radios. It's just like the air, but it's wires. So different type of multiplexing, so-called, is being used in order to accomplish two-way individual communications between all the devices using the same pair of wires. Right. Inline and chain topology are similar. Look, here's a chain topology, here's a ring topology. Inline chain topology as opposed to ring topology. This is the wired as a ring because the last device is connected to the first one and signal can go in a circle. Over here is just first device connected to second device, and that one is just not connected to anything. So there is no a complete kind of a loop. Where is this thing being used? I just put switches, but quite often in the industrial environment, the control modules from one machine to another, that's how they're connected in inline chain topology. Okay, this will be more like a LAN type of configuration here. Okay. Inline chain topology. Now, before I let you go, I'm going to give you some real-life examples using the terminology and equipment that is being used in real-life settings. Okay, so for example, this workstation and the printer are connected in star topology because everything home runs. This configuration here, this printer and this PC are connected to that port in an inline topology. All right, so that was a simple thing here, right? Now, here, a device commonly used, it's called this, well, skip this, Ethernet extender is connected inline with the Ethernet link. All right, the distance for Ethernet cable, Cat5e, Cat6 and whatnot, can't exceed 328 feet end to end, but sometimes there's a longer distance. What can we do? We can plug in some inline, something that's called an Ethernet extender. So the signal is going to go here, it's going to be repeated, and it's going to go here and the other way as well. Now, it's going to slow things down, but if the speed is not the crucial thing, then why not? Quite often used in retail industry to connect cash registers, which is basically a PC, because speed doesn't matter in that case. It's just sending a bunch of numbers every time a transaction is being made. So you're not talking high-speed graphics that you need to display. Okay, another real-life device. This PoE, Power over Ethernet injector, is connected inline with the wireless access point. Wireless access point is an active device. It needs to be plugged in somewhere. And if there is no outlet in the ceiling, then, well, you need an electrician to install the receptacle in the ceiling so that can be plugged in through a transformer or whatnot. Or you can provide the power through the Ethernet cable. But some of the switches have the capability of having power superimposed onto the pairs or to the wires, as well as signal. Some of them don't. If they don't, and you just decide 5 years from now or 2 years from now that you need to get something that can use PoE, then you can just have that device that's called PoE, Power over Ethernet Injector, and that lives in the rack equipment. A bunch of outlets there, bunch of receptacles, power is available, you can plug that in. This thing goes into here without PoE. This thing injects PoE. So this thing is you just plug in Ethernet cable into that device. It's powered and it's communicating. VoIP, we'll talk about those two, but here's your first glance at it. Voice over Ethernet internet protocol. Basically, it's a phone over internet. Right? It is connected in line with the PC. The VoIP manufacturers or companies who produce VoIP telephone systems, of course, they want to sell as many products as possible. That's how they make money. How to make people want to buy your product more than less. Make it convenient for people to install. Well, VoIP involves Ethernet wiring. It doesn't go through the telephone wiring, which means you would have to run additional wire to every office. Or you can design the phone that you can just unplug the PC that is plugged into the wall, plug that jack into the telephone, and from the telephone, go to the PC. Quite popular system in the retail industry. POS, point of sale, cash register station. Whenever you work for one of those big department stores, just take a quick look. Don't go, poking around the wiring because, that'll be bad. But you can see that there's one jack, one VoIP telephone, and from the telephone, the wire goes into the cash register. Okay. Gonna skip that here. Was it? Maybe not. Do we have time? We've got a couple minutes. Consider PC0, PC1, and PC2. Here are the PCs. Are the PCs connected to the switch? Here's the switch. Here's are the PCs. Are they connected in a ring configuration or is it a star? And it's a star, yes, because the physical connection is star. Can it technically be a ring configuration? Technically, you could say that. You could make it a ring, even though physically things are connected in a star, but you can make it work as ring. If you do that, for example, here's a switch. A bunch of PCs are connected to the switch. Now, physical topology is the star. There's an arrow pointing at the wire. Okay. And the logical topology, it can be a star or it can be a ring, depending on how internally this thing is configured. So the signal can travel like that in a ring. A very hypothetical situation. However, I just want to, that's the best way I could explain the difference between the logical topology and the physical topology. Okay. And anything that has to do with the lab, not going to go over that. You will be able to, we will go over that when we get to the lab session. Okay. So what do we have here? We have the patch panel. That's what it looks like from the front and from the rear. Here's the jack. That's, basically for the next lab. That's what we're going to use. And here is the cable with different pairs, and the pairs have twist. We'll talk about what twist is and why we have that. Not going to spend time on that now. Here's just a bit of a difference. Here's the Cat5e and here's Cat6. Cat6 does have a divider inside, physical divider, that each pair lays in that divider. So the pairs are twisted, but also they are laid in the insert there, separator. And that is also twisted in certain way. So the pairs have twist, and the twisted pairs are twisted around each other in a certain way. Later on, in later lectures, we're going to talk about the importance of the twist. Why do we need twist? And insulation displacement connection. We will talk about that next time we see each other because we just don't have time to finish that right now. Okay.